Let's try to understand vision pathway, how it is happening in our eyes. As we know, in our eyes there are two cells are present. One is rod cell, another one is cone cell. So in the retinal periphery region, there are two types of cells are present. One is rod cells and another one is cone cells are present. The rod cells are responsible for the creating vision and cone cells are responsible for the coloring. You can see the structure completely of this eye, but the color is came because of your cones are working. In some animals like cats, dogs, they won't be able to see all the colors because they have not well developed cones in their eyes. But as we are humans, we have good means we can able to see all the colors. In the periphery region, you can see in this periphery region where the rod and cone cells are attached in this manner. And when we try to understand the vision pathway, how this exactly happening, so we need to know about the rod cell, how the rod cell looks. You can see there is a disc is present. On this disc, you can see one GPCR receptor is present. This GPCR receptor also called as a rhodopsin. Whenever the light will fall on this GPCR, means photon is fall on the GPCR receptor, it will create some signaling and the vision gonna happen in the eye. And we can see the mitochondria and nucleus also present, as well as the cytoplasm region also present in the cell. When we try to understand how exactly cell is working for the vision pathway, let's see. This is completely rod cell. You can see this is completely rod cell and this is a disc, and here you can see the GPCR receptor here. Okay, let's try to understand. Whenever light will fall, means photon is fall on the GPCR receptor, means rhodopsin, what will happen here? The alpha, beta and gamma, three units are present in these sites. Okay, alpha, beta and gamma subunits are present beside the GPCR receptor. After falling of the light, what will happen? Alpha subunit will get attached with the GTP with the help of the GIF activity, which is happening beside the rhodopsin. So what will happen after it will get attached with the GTP? It will move towards the phosphodiesterase effector. You can see this is our phosphodiesterase effector. It will go towards, means alpha will move towards the phosphodiesterase effector. After moving towards the phosphodiesterase, what will happen? It will convert cGMP into GMP. Because of falling the light, only this signaling is happening. Otherwise, nothing gonna happen. So this cGMP will make GMP. So because of the cGMP making GMP, so the cGMP concentration will be decreased in the rod cell. After this, what will happen? Our cGMP gated channel will be get closed, and sodium channels also present, they also get closed. So sodium won't be able to enter from this cGMP and sodium gated channel. So the sodium concentration will decrease. As well as there is another potassium sodium pump is also present. This is in open condition, means on in the condition. But what really happening? The potassium is entering inside the cell and sodium is going outside the cell. So again we can say the sodium is again decreasing. Because of less amount of sodium, here what is happening? Hyperpolarized condition is forming and minus 90 volt is forming here. Also we can see the calcium voltage gated channel, like calcium won't be entered into these channels. So what really happening? They are also closed. So this, because of this all conditions, neither here you can see the cGMP is present now, nor the sodium is present. So hyperpolarized condition is formed and glutamate won't be able to release. As we know, glutamate is nothing but this is a neurotransmitter. It can't release from the cell, from the rod cell. So what will happen? Vision will happen. So when the not releasing of the glutamate is creating the vision. But if we are in the dark condition, we are not going anywhere. So what will happen? Let's try to understand. So in that condition, when we are in the dark condition where the rods are not getting light and we won't be able to see what's the things around us, so there is no light, okay, and the no alpha, means GTP will bind with the alpha subunit, so the cGMP will not make GMP, so the cGMP concentration will be high here in this condition. and we are seeing about the when the light is not present. So because of this all, what will happen, these gated CGMP and sodium gated channels are open. Okay, you can say on. In the on condition, so sodium will be increasing this condition and not decreasing here. So the hyperpolarization condition is not happening in this condition. There is depolarization. Depolarization condition will occur. Because of the depolarization condition, what will happen? Glutamate won't be able to stay here. It will make vessels, and with the help of vessels, what it will do? It will release in the outside. After it will release, what will happen? The no vision will gonna happen. So whenever you are not seeing, so the glutamate is releasing from your eye and you are not creating any vision. But once the glutamate stop to release from the rod cell, then you can say the vision is happening. So this is what really happened in this condition. And we want to see another thing about the rhodopsin. The rhodopsin is made up of two things. One is protein, which is known as opsin, and another one is chromophore. Chromophore is nothing but 11-cis retinol. This chromophore is came from the vitamin A. You can see the vitamin A is responsible for the giving the chromophore to our eyes. So because of this, what will happen? This is a molecule responsible for the vision. You can see here is the opsin and the 11-cis retinol is present. They are attached to each other in this dark condition and inactive condition. Means there is no light, so they are inactive. Whenever light will fall on the GPCR receptor, opsin will still same, but these 11 cis will convert it into the 11 trans. So the 11 trans will form in this condition, and light will means we can say the light is present in this condition, and they become active and unstable. So because of this, what will happen? We will get the vision. Are you getting my point? Here the opsin is present with 11-cis retinol in the dark condition and no inactive condition, but the opsin is get attached with the trans. So the cis is getting changed into the trans condition. So the cis is converting its structure into the trans. So that's why we are calling it as 11 trans retinol in the presence of light. So they are in the light, so we are calling it as a light, and it is in the active state. And this 11 trans retinol is unstable completely, so we will get the vision. After a time, what will happen? Opsin will be remain same, but these 11 trans retinol will be converted as into the 11-cis retinol in the dark condition. Again, it will come into their own structure from the trans to cis. Then again they will form the rhodopsin. So this is what happening inside our eyes. I hope you understand.